All right, everybody, thanks for joining us today. Thanks for coming to the Computer Science Colloquium. We're very, very happy to see the audience here, and it's a real honor and pleasure to have Steve Schveighoffer and Ali Çehreli with us. Both these gentlemen I've known and have been friends for several years as part of the D language community. And again, these are folks who have many, many years of engineering experience and are going to be talking about the D programming language. I'll let them do some more introductions about the topics that they're talking about, but learning and using D in the real world. If you have questions, feel free to raise your hand. We'll also have time for Q&A. But luckily, we're going to get two great talks, so half the time for Steve, the other half for Ali. And without further ado, let's welcome them with a little applause here, and we'll get going. Thank you.
Thank you, Mike, and thank you, Yale, for having us back for this talk. It's really great to be here again. My talk is kind of cover both learning D, using D for learning from a teaching perspective and also from a student perspective. So, who I am? I have a Bachelor of Science from Computer Science from WPI, and I have no formal training on teaching, but I have done some teaching as a homeschool parent for two kids. And I've been a professional software developer for over 25 years, lots of experience in different programming languages. And I've been a contributor to the D language since 2009. This is my GitHub link if you want to look at some of the projects I've done. Also, just a disclaimer, this is all my own stuff and nothing from my employer, who does happen to use D in some of their projects. Yeah, so this is my GitHub. You can look at the projects I've done. So let's just start out with what the D programming language is. Use Dlang for searches if you want to search for stuff on D. I'm just going to bring this up here a little bit. It's a compiled imperative language, very similar to C and C++, and a bunch of languages in that vein like Java, Swift, those kinds of things. The biggest difference is the official memory allocator is the garbage collector, but that's optional, right? You don't have to use the garbage collector when you're using D. But you know, it's very nice to have it there. We have polymorphic types in classes and RAII types, for those who are familiar with C++. We use templates for generic code. So if you're not familiar with templates in C++, is basically just copy pasting a code with some substitutions in there. We have compile time, reflection, and introspection, which is probably one of the most powerful pieces of D. And we have easy C and C++ interop, so you just basically can call C functions or C++ functions pretty much. There are some limitations for C++, but for C, there's almost no limitations. We have a safe subset of the language, which allows you to, the GC is really the biggest memory safety piece, because when you have a GC, you don't have to worry too much about using dangling pointers, but you still have stack memory you can point to, so there's a safe subset of the language that doesn't let you accidentally use those for the most part. One of the biggest benefits of D is if we have very fast compile times. So for instance, the D compiler, which is written in D, takes up like 6 seconds to build, versus if you try to build like GCC, it's on the order of 40 minutes or something. We have a script-like runner, RDMD, which helps you write D code, and you can use it for scripting. I'm going to go over that a little bit later. So my experience teaching D, and keep in mind these are like 10 to 14-year-olds that I taught, so they weren't really super experienced, not like you guys. So I had two groups of students. The first one was my kids plus some of their friends who begged me to do a coding class for them. And we did a little bit of JavaScript and Lua, but we eventually moved on to D for more advanced video game programming, we use the library Raylib, if you guys are familiar with that. It's a really nice C library, and because D has easy binding to C, we were able to use that. And we tried out some networking, but I wrote most of the networking parts, but allowed them to, use that. And kind of a funny story, at the end, I asked them, what kind of project do we want to build? We can build a game that everyone can use, and their concept that they came up with was a networked rock, paper, scissors game, which I don't know why that was interesting to them, but they were all for it. The second group I taught was at our homeschool co-op, and again, similar age group. At this point, my youngest son had already had experience in the first class, so he was more intermediate, but most of them didn't have a lot of experience with programming. And we started with very basic lessons. This one I started out with in D, and just wanted to kind of prove that you can use D as a nice learning language. And we moved on to Raylib programming again, and we built an actual kind of a game together. It didn't, it's not a complete game, but if I have time, I'll show it to you at the end of the presentation. And this is the website that I made to kind of teach them the lessons. It's not really completely filled out, but if you take a look at it, you can see kind of some of the stuff we did. So when you're learning with D, what I kind of like about it is that you have layers of complexity. So you can start off with something relatively easy. You have this import std at the top, which basically imports the entire standard library. So you can give students kind of like this is how you introduce them to code. There's no memory allocations you have to worry about. You can see basically from this, I think the most difficult thing to understand here is the void. But you get an idea of like the things you can do with D without, learning too much. So, that I think that's a nice way to introduce kids to programming. We have built-in types that are similar to a lot of other languages. The ones that are similar to C and Java, you see at the top there. Then we have the unsigned versions of most of those. And the other addition is like byte, which is a 8-bit value versus character, which in C would be what you would use. Array types are declared consistently. So this is one of the things that always bugged me about C, is where you put the indexes and what order they go in. D is always uses the index on the type and not on the variable. Arrays carry a length with them, so you have bounds checking, another safety feature. And string is just an array of characters, so there's no complex string type that you have to deal with or understand with member function or anything. It's just this is an array of characters. There's a dictionary type included. We call it associative arrays. You declare it with a value key syntax like that, and you can see an example of how that's used there. So D has nice flow control. We have all the usual suspects for loops, like for, while, do while loops. And for each can take care of most of these. You can kind of see if you're familiar with the C way of doing things. That's a for loop in the top, but you basically loop 100 times there. And the other ones give you looping over a structure completely. So you can also hook loops for custom types. We're going to go over ranges later, which is what allows that. And we have string switches. So in C, you only have switches on integer values. And D, you can use these string switches. And you can kind of see we do support Unicode here. So, with the for loops, I don't know if you've ever used in C where you run into issues with unsigned comparisons, but if you use a for each loop, you won't have this problem. It should take care of everything for you. Excuse me. D has modules and forward references, so you can declare things in any order. That's a kind of nice feature. You don't have to pre-declare things. We have renaming of modules. We have renaming of symbols. You can import at any level, so any place you import, it's just for that scope, and the symbols go away for when you leave that scope. So you have a lot of nice power there to determine what your namespace looks like. This is one of my favorite parts. D has nice foot gun prevention, if you guys know what that means. All variables are initialized by default, so you don't have garbage that you come up with, if you forget to assign a value to a variable. We have a built-in unit test system that allows you to test your code, and you write it inside your module just along with your other code. Global variables are thread local by default, so if any of you done any multi-threaded code, this allows you to basically skip most of the issues with synchronization. Any variables that are shared between threads, you have to actually declare them as shared. We have safe functions that disallow memory safety issues, and things like the fifth bullet here, where you have if A equals B, but can't be is an error, so you have to declare it as A equals B equals not equals 0 or something like that. So it prevents you from making those simple typo mistakes. The next one is one that I don't know if any of you guys have ever done this, where you put a semicolon after the if statement before doing the actual statement. I've spent hours on that. So if the compiler yells at you and you just realize that saved you like a couple hours, that's really nice. We don't allow implicit truncation, so you can't assign an integer to a long value, which is a 32-bit value to a 64-bit value. But if value range propagation can detect that it would fit, then it allows you to do it without requiring you to do any kind of casting. So this is kind of a thing that makes it easier for students to get going. They're not running into all these kinds of weird little issues that you have to kind of explain the underlying details of stuff. Custom types are designed for their purpose. So we have classes which use runtime polymorphism, just like kind of like Java interfaces and base classes. They're always reference types, so there's no object slicing. They're usually allocated with the GC, or you can allocate them other ways, but for the most part, the GC is what you use there. And they have protection attributes. Both types have protection attributes that allow you to define who can access the symbols inside them. Structs follow the C compiler layout, so the C compiler that's native to your system, it'll lay out the structs the same way, so you can actually define the same structs that are used in C and use them, no problem. You can just call C functions with those. RAII access, support there, and both of them support operator overloads and an implicit disk parameter, which is kind of in contrast to something like Python, where you have to declare the self parameter. And one thing to note here is that private is private to the module and not to the class or struct. So that kind of catches people a little bit, but it's kind of a philosophical decision that we usually like. You kind of get used to it. But D is not just simple. We can do advanced features. So we have pointers, just like in C, even though we have a garbage collector. We have const immutable attributes, which prevent you from changing things if you declare it that way. And we have inline assembly. So anytime you need to actually write assembly, instead of creating a new file with a assembly syntax and compiling that with an assembler, you just write it inline, and that works. So one of the things I like to point out is that the designer of the D programming language is a person who is one of the only people who wrote a C++ compiler from scratch, Walter Bright, and he used that experience writing that compiler and dealing with all the problems that happen there to guide how he designed the language. So a lot of the things you'll see here are based on that. So let's see some more advanced features. So by the way, like, I never got to these things with the young kids, but you guys definitely should learn this kind of stuff. So this is how templates work in D. They're a little bit different than most programming languages. I think most programming languages use angle brackets for their generic parameters. But in D, we just tack on an extra set of parentheses. So anytime you see extra parentheses there, then that's a template parameter list. You can use types, values, anything you want as parameters. Then declaring an instance of a template, so instantiating the template, uses this interesting syntax where you put a exclamation point with the parentheses. And it's hard to explain this without experiencing it, but it makes things a lot easier to use, I think, when you're deciding, what is this kind of a call or instantiation, instead of the knowing when to put the angle brackets. It's like, this is obviously an instantiation. And then I didn't put it on this slide, but because it wouldn't fit, but you have template constraints. So if after your template you put an if statement, you can tell it which certain constraints that have to happen in order to instantiate that template. So this is kind of like a concepts type thing. Ranges are something that is like a pair of iterators in C++, but I think C++ now has ranges, right? Yeah. So they actually stole them from D. But this is what we use for our iteration primitive. You have 3 required members, front empty and pop front, which are pretty self-explanatory there. And they're generally used via algorithms and loops. So you can see in this example code, we have an array. We sort the array and then pass it to a retro function, which reverses the result. And the output is, as expected. So on top of that, we have uniform function call syntax, which is a nice transformation. If you have a function, if you have a type that or a value A, and it doesn't have a member function named foo, what will happen here is it'll rewrite it to the second part, and if there's a function that takes that type as the first parameter, it uses that. And it only happens if there's no member function there. So it allows you to kind of add methods to types, including primitive types. So even like an integer, you can add a function to integers. And it's very useful in range pipelining. So if you remember from the previous slide, we had this kind of inside-out writing of how things happen. Instead of that, we can write it the second way, where we just say array gets passed into sort, which then gets passed into retro. And you can read that very easily and write it easily. It just makes sense. And because D allows you to omit empty parentheses, this also you can write this way. And it's basically the same thing. So you can write a nice long range pipeline, and it reads very well. So this is another thing that's really nice in D. We have any function that has a body or a source code available, you can call at compile time with these restrictions, but only for that call. So you could have, let's say, a function that uses I/O, but as long as the way you call it doesn't end up using the I/O, you can call it at compile time. So you can call sort at compile time. You can call anything at compile time as long as it obeys these rules. And there's actually a special variable called CTFE where you can check to see if you're on compile time and do different branches of code. Like, for instance, you could use malloc in the normal branch, but then use the GC in the compile time branch. So there's like lots of ways you can use this, and it ends up being a really nice way to generate code. And then it's only activated when you need it for compile time. So these are the situations where you would see it activated. Introspection and compilation. So compile time properties such as type of or size of, and traits calls. There's more than 50 traits calls you can use to query information from the compiler. And these things allow you to check things at compile time, use static if or static for each to determine how you're going to compile things. So when you're writing generative code, this is the way you're going to do it. We also have version statements that say like, oh, this is big endian machine, or it's a Windows system or whatever. So you can write different code based on that. This is kind of like all the pound if defs and stuff you would see in C. Instead of that, you have these introspection and inversion statements. String and template mixins are kind of like the macro system of D. So you use CTFE, you can build strings, and then you can take those compile time strings and just call mixin on them, and it's like you wrote that code there. So instead of the macro system like in C, where you have basically a complete string replacement of anything, including this, changing the syntax. You can only use these in certain ways. So it's impossible kind of to abuse. I wouldn't say impossible, but it's very difficult to abuse this to turn your program into a language other than D. And then the template mixins allow you to write just normal D declarations, and then you can just put them anywhere you want as if you type those in. And then finally, the scripting features of D. So D can somewhat be used like a scripting language, even though it's compiled, because it's really fast to compile. We have this import std will import all the standard libraries. So if you're just writing a script, you don't care to go look up where symbols are defined. You just say import it all. RDMD, the command, basically will compile the program. If it hasn't been compiled, store it in a cache, and then run it from there. The next time you run it, if it's already been compiled and nothing's changed, it'll just reuse it. So this way, it just feels kind of like a script instead of actually doing compilation. And we support the pound bang syntax, so on Unix systems, you can just run a text file in it and it works. We also have simulation of dynamic typing. So the variant type is like a box type, which can hold any type of value, and you can get the type out of it. You can extract it when you need it, or it supports simple addition, subtraction, those kinds of things. We have auto type inference, so you don't have to type in types all the time. You just infer the type. And op dispatch is kind of an interesting feature where you can call a function on a type that doesn't exist, or use a field that doesn't exist. And if it has this op dispatch member function, it will call that member function with the name that you used as the template parameter. So you can basically define things as they get used. You could think of it like if you had like a JSON object and you wanted to set X to whatever, it will intercept it here, and then you could put it into it like a dictionary or something. So that's a very cool feature. The ecosystem of D is similar to Node NPM, where basically you have this program called Dub, which will download dependencies for you, compile them, link them automatically, give you lots of different features there. So building a system with existing dependencies is as easy as just saying, yeah, I depend on this thing, and it'll automatically do the downloads for you. We have import C as well. So import C is a full C compiler inside the D compiler. The only thing it doesn't have is the preprocessor, so we have to kind of steal that from the existing C compilers. And you can use this to basically include C headers without having to replicate this as bindings. And this is kind of a newer feature, and it's not complete yet, or there's some issues with it still, but for the most part, it works pretty well. I know people have compiled like libz with the decompiler and things like that. Yes, Ali. Yep, Ali uses it, so it must be good. I also use it. It's really nice. So, kind of in summary, I know there's a lot of languages to pick from when you're doing projects or for teaching. I think in the last decade, there's like 200 languages per week that are invented or something like that. But the nice thing about D is that it kind of meets you where you are. So if you're a basic, you haven't learned a lot, you can still use D, use the basic features of D. And once you get past that, once you've grown in your abilities, then you move on to newer things, right? So straightforward syntax. I think the largest complaint I got with the students was semicolons, like having to remember to put semicolons. But other than that, it was like, okay, yeah, we can use this. It wasn't too bad. And beyond this, I think this slide is basically as far as I got with the young kids. But as you get more advanced, learning with templates, one of the things I was mentioning to the students we were talking to earlier is even if you're using C++ or whatever to do template programming, the way templates are in D and the compile time programming in D is, it makes things a lot easier to understand. And then when you start looking at the C++ code, which is usually horrendous, you can kind of understand where it comes from or what's happening under the hood. You're not fighting with the syntax plus trying to understand what's happening at compile time. So it's still a benefit, even if you're not going to use D in your project, to still learn with it. And of course, the higher levels, you get compile time introspection and static if and for each, and when you get to the top level, like generative code, so you're basically building code that builds code. You can even make domain-specific languages at compile time. I'm going to give you an example here. So this is a library that is pretty well known in D called the Diet template library, and it's used in web servers. So essentially, you have a syntax on the left. If you look at that, that's just a file that you write, and it's basically an HTML file, but in what's called like Pug. I don't know if you guys ever used Pug, but it's a simpler syntax, so you don't have to repeat the closing tags. And you can see in here we have interpolations that come from the D side, and in fact you even have decode at the for each loop there. This is all just like a completely different language. But if you look on the right side and you see that render line loads that file at compile time and parses it, turns it into an AST, and then rewrites that file as decode and then compiles it directly. There's no need to actually do an intermediate step. It's all done by the compiler. So this is the kind of power that you have. And if you have any errors, it'll tell you where the error was in the original file as well, like the line and everything. So this is pretty amazing that you can do this. And then if we have time, I was going to show the game that the kids designed. So let's see if I can get this to work. So this is let's see if it comes up here. It came up over here. I'll just have to drag it over. But I didn't do any of this code. They made this. There's no sound coming out, but there's like little footstep sounds. And they even, this thing where this is supposed to be a key where you can get out as you get closer, it gets thing. And then there's a button you can use to open the door. And then there was another thing where if you hold down this button, you can see like so you can actually walk into the bed and stuff. But this was all the artwork, everything was designed by these, 12-year-old kids. It was pretty cool to see that. But this was all done with Raylib and D. So, and yeah, that's my presentation. That's it. If anyone has questions.
Ollie, we can start getting it set up, and then if everybody has any questions for Steve, feel free to ask here.
Yeah.
Ed,
Yes.
how long start to finish for that project for the students?
That was like a session, so I would say like 6 weeks or something, or yeah. But this was after like a 6-week session of first building up to that point. So
12 weeks, less than a semester.
yeah.
Is there any benchmarking of the runtime performance of compiled C++ code versus compiled D code? Are we comparable?
Yes, it's very comparable. We use the same backend. But there's 3 different decompilers. There's the reference decompiler, which is the one that builds the fastest, but it doesn't have the best optimizer in it. Then we have an LLVM backend one, which uses basically the same thing as Clang. And then there's D is also actually a part of GCC at this point. So whatever the GCC backend will do. So yeah, we've actually done, projects where a bunch of us have made like the fastest whatever benchmark game winner, whatever. So it's there's no real detriment to using D over C++. The generation is just the same. Yes. So we use the same thing as Java. So there's no multiple inheritance of fields, but you can have multiple interfaces. There are libraries that have done multiple inheritance, but it's all done in the library, kind of, so you have to follow their structure.
Any questions?
All right.
If not, let's get all these set up here.
Okay, hello everyone. My talk is about Dlang, the way it's used in the real world, even though it's a very small community of programming language. It actually gets used, like myself. So this is a little bit introduction of myself. I'm a self-taught software engineer, like Steve. I have double E background, physics master, but never had computer science, but learned it on the job myself. I come from a C and C++ background, like compiled languages. In the D community since 2009. So these days I'm semi-active on the D forums. In the past, every day I would be there answering questions, asking questions in the discussions, but I've grown older a little, so I slowed down on that aspect. And I'm an occasional presenter at DConf now, not at every DConf. But I'm most famous for this third bullet point here. I self-published the book Programming in D, which is freely available, and all of these are links, of course. When I give the PDF, you can click on them. It was a happy accident, as that happy accident blog explains how it came to be a book. And I've been involved in multiple communities, a founding member of the D Language Foundation. I co-organized the Silicon Valley Dlang meetups and Silicon Valley C++ meetups, both of which are defunct right now. Unfortunately, after COVID, everything slowed down. We don't have in-person meetings anymore, neither online anymore. I used D in 2 different companies. I work at the top one here, autonomous driving tools at Mercedes-Benz Research and Development. The first project I used D in was ROS bag file manipulation tools. The second one is the current one, where I designed and implemented a differential software update algorithm using D. And before this company, I worked at Weka, which is an extremely fast data delivery company product based entirely on D. I will have a slide for that one coming up. I will skip this quickly because I also built up some slides to describe how powerful D is, but Steve has already done a great job on that. This is a general definition of D. On the PDF, you can flip through it. And I like this slide too. D is against some odds. Most of the successful programming languages have something that D doesn't have. For example, some language becomes a famous language because they come with a killer app. D doesn't have that. There's always a major, or sometimes a major corporation behind a language. D doesn't have a major corporation pushing for it, etc. So it misses on all of these topics. Still, it's so useful that so many companies use it and benefit from it. I am stealing the following slides or ideas for these slides from Simon Arnold's DConf 2007 presentation, because he presented D in a very wide range of use cases. For example, the TSV utils used the keep calm and write sensible code approach. TSV did not do anything special. They did not attempt to do any high performance coding. John Degenhardt just used D as it is, and I will skip this performance comparison, and he beat everybody else's existing tools. They were tools written in C and C++ and other languages out there. He wrote the same tools for their company, eBay, for data processing, and his tool, the D program, were faster than all of them. Most of them, let's say. And funny story, of course, when the original authors of those tools realized they were being behind, they went in and optimized their programs, and they became fast too. But this shows that you can just write D in a sensible way without thinking any performance, and you get a very high-performing tool. Next example is mere numerical library. This uses D as a better C approach. D has a subset where you compile it with a dash better C. It avoids the D runtime features, most of them, and then you use D just like C, as low as possible, as close to the bare metal as possible. So mere numerical library is had very high performance when it was written. It's probably better these days. Auburn Sounds is by one of the D community members. It uses @NoGC approach. It still uses the D runtime, but puts @NoGC attribute to functions, which disables the garbage collector. Because it's a latency sensitive code, Auburn's sound processing products cannot afford to have garbage collection glitches, those times lost there. So that's how it is used. And then I think this is Simon Arnold's own project. He called his project a horrible hacks approach. He wrote some code that boots on bare metal x86 at the lowest level. It's a vertical scrolling shooter game, that was, and we've seen the demo on DConf. If you find his presentation, you can learn more about that too. The next company I will give as an example is Symmetry Investments. It's an investment management firm based in London. They use D to design and implement a domain-specific language specific for finance topics. This is all I know. Some other people may know better. Symmetry is the main DConf sponsor. When DConf happens in London, they provide the space and many other amenities. Symmetry also runs the Symmetry Autumn of Code program, where they employ students that pay them money to work on D projects. This is similar to the Google Summer of Code. Now, Weka.io is a company that I mentioned I worked for. This is a great example of a CTO, or CEO later on, Liran Zvibel, the first bullet point at the bottom three group. This company is a company experienced as data delivery. This was a storage company, data company in their past lives. A group of startup engineers used C with crazy macros to achieve what they had to do, to achieve tremendous performance, because in data storage you have to, what you need is performance to reach that data, to bring it from the storage. Then Liran Zvibel happens to know about D and realizes D solves all the magic that they had to create in C with C macros, code generation. D already gave it as out of the box. So he looked at D, even though D wasn't as complete as it is today. He took a chance and brought D into the company, and now Weka's entire technology is based on D. From the device driver level all the way up to the user interface, the user interface of their product. It is so high performing, and if you watch Shimon Ben David. Apologies. Yes, I generate these slides in Emacs. Okay, Shimon Ben David and Eyal Lotems. If you watch that presentation from this year's DConf, Shimon made a joke actually, which happened. He would go to the customers with the sales sales manager, and they would have to lie the customer that their product is only 6 times better than the competition, even though it was 60 times better than the competition. So their data delivery speed is 60 times or more now, probably better. They're better in every respect, and they've managed everything, the entire technology on D. I also recommend the third one, of course, again from this year's DConf by Eyal. So this is another example. To me, it's the flagship example of D in the industry. Remedy Games used D for a while. It's a AAA company which uses, which has to be extremely fast. This is an example, another example, but I don't think they use D anymore because D was used as long as D community members worked for this company. It's probably fallen out of fashion there. And those people were Ethan Watson and Manu Evans, both of which are strong community members of D. Now, here came another amazing talk from this year's DConf, Louis Nicolle's game engine. Louis used to work in AAA companies, in gaming companies, and as a side project, he decided to write his own game engine in D. I copy-pasted the top group of bullet points from his presentation, but if you click this link and watch what he did with D, it's amazing. The game is based on mirrors. You're in a world where you can go through mirrors to as portals. You go into different sides of the mirrors, and every time you do this, the reality flips because mirrors flip the reality. And he's achieving 60 frames per second with, I forgot how many, but you have so many mirrors in the world, and as you flip through, everything flips, you pass through. And he still achieved 60 frames per, oh, there it is, 150 nested mirrors in a scene, for example. What is cool here is, if you talk to any D programmer, you will find that D programmer defending the garbage collector. Because if we talk to any C++ programmer, they will, like a religion, they will shun us. You know, your language has garbage collector, no way, etc. But in this game that I'm talking about, which he achieves 60 frames per second, he did not turn the garbage collector off. He uses it. But he doesn't use it in the game loop, of course. He freely uses the garbage collector when the game is building up to its game loop stage, maybe later on, maybe occasionally. But it's not a religion, is what I'm trying to say. You can take advantage of the garbage collector, as I do in my current projects, as many people do. And you can still avoid it if you don't allocate dynamically in your tight loop, game loop. And there are so many other companies and projects that use D. This is just a selection I found on. If you click this many others, it takes you to the DConf, Dlang's website, and there's a list of companies actually using them. And it's used in academia, as you know, Mike Shah uses it, and other people use it. And the reason it's used, I gave a list here because it's a great software engineering tool. I will pull your attention to the bottom part, the emergent properties. So you start with a programming language and write your project, which I've done with C, C++, and some other languages. And I found, for example, C++ to be difficult to mold. As the requirements of the program changes, it's difficult to shift your program into this other mode that will support that new requirement. In D, we find it a very easily refactorable program. There are these little friction points in C++. For example, the constructor's name has to be the same name as a struct or class. It's sensible that they decided with it. But Walter Wright chose to make the constructor's name this. In every class and struct, it's always this. What's the difference? It doesn't matter, right? Any name. But when you decide to change the name of your class to a name that more represents better what that class does, now you have to remember to change all those constructor names also in your type. So it's such a simple thing, and you may not agree with me that you can do search and replace. But these little friction points actually hurt you in actual engineering, in development. If the language doesn't give you any friction and you're freely flowing, you change things around, you move things around, and you actually have fun with your project. That's what I find in D. And I always repeat, I secretly hope my friends who are the users of my tool come to me with requirements saying, hey, can we do this? Oh, thank you. Yes, let's do this. After all the years, and okay, this is going to show my age, but I've been in software since '89. It's 36 years. I'm still having fun writing programs and shifting code around to turn the programs into better tools. D is a multi-paradigm language. I will go very quickly. You can do imperative coding, low level, object-oriented, generic, generative. Steve also mentioned a lot. Functional. I will not stay on this functional one. This is a mind bender. But if you get to PDF, just look at these examples. Pretty cool stuff. Steve also gave an example of this, right? File foo.txt means open foo.txt file, iterated by line, filter according to this predicate, the ones that are not empty, map each of those lines to capitalize, and take the first 42 of them. And this is all lazily evaluated. Not all of the lines will be capitalized, because take will take only 42 items, and there will be only 42 capitalizations. We talked about this during our tea break. The static if is amazing. If you're defining a range, let's call it my range, and it depends on a template parameter t, you can say static if, and you can say this at compile time. If t is infinite, and you can detect this at compile time from the types, introspect on the type, and is infinite will tell you whether t is infinite or not, then you can define your empty property as an enumeration, a compile time constant, not even a function. You can say false. So if the type I depend on is infinite, then I will be non-empty. I can't be empty ever. I will go to infinity. Else, if that's not the case, now you can define your empty, length, and up-index properties as your type needs. And this is a feature C++ creator himself, Bjarne Stroustrup, objected very strongly. He even wrote a very low quality article to defend their position. I call low quality because it was written very quickly, with typos in it, and with not strong points. But they had to object this feature, because this feature is not mathematically complete. There are so many holes in it. So they are right. But at the same time, the feature is practically so useful that all D programmers will make use of this, and it helps a lot. D is very low level, as Steve also mentioned. Assembly blocks, bit operations, pointers, these are C-like features. But it can go as high as you want, and every presentation of mine always has parallel. Imagine that parallel is not here. Then all your files will be processed in sequence, one file after the other. But if you put dot parallel, all your files will be processed in parallel on all the cores you have on your machine. 8 cores, 20 cores, they will be processed at the same time, and you gain this free speed. Or some languages have this pattern matching feature. D does not have pattern matching, but somebody wrote a sum type. This is in the standard library. You can say, let's match the actual temperature type, which may be represented as Fahrenheit, Celsius, or Kelvin. Now this will always represent the Fahrenheit value. So these high-level usages, as if your language, as if D has these features, are implemented all by these features. you could have implemented all these high-level features, and you could have written your programs according to your requirements at these high-level helping features. Unit testing. We talked about this at lunch, at tea break again. Let's say you have a function called repeat. It will take a string and repeat it count number of times. All you do is put a unit test block and assert that if you call repeat with A, B, C, and 2, the output will be this. Or if you repeat A by 0 times, you will get an empty string. This is an extremely useful feature. Both tests your functions and also works as a documentation. By looking at this, you know what that function is supposed to do. Are there any questions? Am I going too fast? Okay, we'll ask questions later, hopefully. Let's skip that. Okay, Steve mentioned all of this beautiful stuff, but I have a long example here. Naturally, in other languages that do not have UFCS, you start from inside out. I start with values array. I will multiply each element by 10, divide each of those results by 3. I will take the even numbered ones and then write them on screen. UFCS allows you to write it in a more natural execution order. Values, multiply 10, divide 3, evens and right line, or you can format your code top to bottom. And I use this a lot. It produces a very readable program. Okay, here is some experience, not really related to D. Okay, let me stay on this. This applies to almost every language. Some functions return integers as error codes. A non-zero means error, 0 means success. But then sometimes these error code domains mix up. So I think this is an inferior way of returning error. For example, this code calls foo, gets an error code. If error, returns that error to the outside world. But does this error that foo returned within the error domain of bar? Like 1 may have meant something to foo, but if you kick it out, it may not mean the same thing for bar or the color of the bar. And I had these problems myself in every language that has return codes. It's not that simple. You need to translate sometimes. For example, in one case, one library call was returning 0 as the error. So you would have to translate from that to your caller. So translation is required. Unbelievably, now this is very modern. Many modern libraries use Boolean to report success or not, but they chose the wrong side. In the other side, false would mean success. Now they changed it, so you have to be very careful with this. Like that, yeah. Anyway. And also the return value is so precious for functional programming, right? You don't want to waste your return value for your error reporting so that you pass in a pointer here to get the result out. This doesn't make sense. That's why throwing an exception is a better option. You just do this, double result equals square root x. If there's an error, it may throw an exception, and you continue. Exceptions have their own problems. That's why currently I use an optional type. Optional tells you whether there's a usable return object or whether there was an error. It combines both of them together. Okay, I'm almost done actually. That 41 over 42, you don't see that number there. So I will philosophize a little bit here. So choosing a programming language, it's very common to go to the websites, forums, and realize people comparing feature lists of programming languages. Or sometimes they agree with the marketing of that language. And I'm hiding, I know there's a recording here, I will say the names of the programming languages here. For example, the Go programming language marketed itself on inaptitude, which I still find as a little bit of shame, because they said that the new college grads cannot handle the more difficult programming languages. So we designed Go for them, the new engineer who joins Google specifically. So they market it for the inexperienced programmer. Safety comes from Rust. And being a member of an exclusive club, I'm attacking C++ here, because to be a C++ programmer, to be a correct programmer, you have to work really hard, read books, and follow more than 400 items of a coding guideline, core coding guidelines. Without obeying those rules, you cannot produce correct and high-performing programs. Even though I know C++ is also evolving and bringing higher level constructs to help with that. So you have to agree with the marketing. Whatever pops up, you have to follow it, right? But then I also bring this emotional reasons down here. Because when I look at the D programming community, there are people who stay with it for a long time, like Steve, myself, and so many other people. They don't stay with D because D is better than other languages. They stay with it because they have an emotional connection, sometimes to the creator. Here, receiving a response from the creator of the language to your email. I know one person who came to DConf as a speaker himself, so thankful that he emailed Walter Bright, the creator of D, emailed Bjarne Stroustrup, emailed other creators saying, hey, I'm going to learn programming, and he didn't have any computer science background. He received only one response from Walter Bright. So what I'm trying to say is most of us are in this community because we feel close to this community. Like we have Timon. He will drag D on the ground for its deficiencies, but he's still in the community for decades to come. He will not let it go because you feel close to that group, and that's your language for that reason. Mine is that reason because I resonate with the leadership of D. I resonate with the people in there. So that's why I wanted to put it here as a let's say big brother to you. Because in the past I was also racing with feature comparisons, but please don't lose the human aspect of not only programming languages, but everything else in the world, especially when AI is attacking us, robots are coming. The most precious thing is your humanness, so choose whatever you want as you want it in your heart. And finally, this is my simplicity slide, the last slide. During my C++ times where I was becoming a C++ expert, perfectionism was the goal. All the 400 rules you had to memorize, and you had to follow what your bigger brothers in the C++ land that you admire told you to do. Do this, do that, don't do that ever, kind of thing. Now I've been there, I've fallen. I don't care about perfectionism anymore. What you want to do and what makes sense is engineering. You use a programming language to achieve a goal. You're writing a product. You're making a tool. Whatever takes you to achieve that goal, do that. Don't obey perfectionism rules. So that's why my code is now very simple, readable, manageable, and I don't care about patterns. Whatever is the hype of the day, I don't do dependency injection just because it's a cool feature. I don't do any pattern, follow anything. Simplest thing. So today, I'm not lying. I start with a simple struct, and I start with freestanding functions that work on that struct, just like C. But D is better C, of course, much, much better C. But then eventually an invariant pops up in your type. Then you put in member functions, you move the functions inside because D is so easily moldable, everything works. So that was my big brother moment. Thank you for listening. That's it.
Questions for Ali, the speaker, or Steve?
Wow, I answered it so well. Oh, okay, there's one.
Yeah, there's something kind of magical about like you're starting from scratch and you can pick any language you want and then you go like, oh, Dlang. And you mentioned examples of like, you know, these two guys who are working on Alan Wake, whatever the other name says. where, like, I guess when they were working on these games and they were starting sort of a little community within that company that liked using this language, I guess that's nice, but then they leave, and then maybe they start shifting away from that. So it seems like most of the time you're entering into a scenario where, you know, other people have their favorite languages, you try yours, you would like to learn your favorite. I wonder, like, what kind of experiences you've had with that. Like, have you had the sort of privilege of being able to decide what you work on, or when you're working with a team that doesn't want to do language?
Yeah. So the question is, how can you be lucky enough to choose whatever language you want to use? Because whenever you join a company, the libraries, the tools over there are already written. And there's a group of people who are accelerating towards other languages like Rust. Where I work, Rust is a magnet pulling people, at least 2 years ago. I don't know what they do now. So the answer is, go work for a D company if you want to use D, really, because it's very rare to find a company that will allow you to use D. I'm so fortunate that I joined Mercedes-Benz Research and Development, and they respected me with my past experience. And when I came in, they presented a problem, and I said, you know what, this fits D language a lot. Let me write it in D. And once you wrote it in D, and the tools were so useful, and I'm not making this up, hundreds of developers were freed from something that was blocking them, and there's your respect. And after that, they came to me, hey, we have this problem, do you want to solve this? Oh, right, of course, D. So you have to be lucky, really, to get there. I agree, and yeah. There's no answer. You have to be lucky to find people with that open mind. And all of these companies you see, some of them working on transportation companies in Europe, these people are all luminaries because all other languages already existed when they decided on D. You need to maybe levitate towards people who are open-minded. And so sometimes I throw names of people like Steve Jobs, I think, is a person like that, or some other people. When you look at these people, you realize they shape their world to what they want it to be. For example, an anecdote I remember, Steve Jobs did not buy a sofa until he found one that worked for him. So I see the people in the D community, people like that. They look at it, they know what they don't like in C++ or other languages. And there's a saying by Walter Bright too, nobody will fire at CTO because he chose C++. So that's the norm of the day, or maybe Rust these days. But these people looked at it and they saw, yeah, I've done that before, I don't really like it, I want to go to this new site. And they worked hard for it too. The WECA, for example, contributed D a lot with ideas. They hired people to fix bugs in LDC, etc. So levitate towards people with open minds, I think. But your point is excellent. I'm just very lucky to use D in a C++ environment. Yeah. I couldn't hear it. What language? Oh, really weird. No, I've seen really weird languages. I programmed in Python. I was actually forced to edit, sorry manager, edit a colleague's Python code. I can't understand how people can change Python without breaking it. So you change something, done. No, it's not done. That code path still does have that other variable. You forgot to change it, Python. I used Go for 1 year. Before joining Mercedes-Benz, actually, exactly 1 year. And with Go, my experience was you complained for 2 weeks, and then you gave up and coded the way it wanted you to code. You accepted the limitations, and it just went that way. It was a startup company. I had to use Go because the CTO had chosen it. But to be honest, Go was a perfect fit for what they were doing because every library they needed was already written. Go was just gluing those libraries. Yeah, sorry, no, I haven't used a weird language.